Hello everyone. In the last session, we discussed the types of solution. So in this session, we will discuss methods of concentration. So before going to methods of concentration, first we know what is the concentration. The concentration means the specified amount of solute present in specified amount of solvent or solution is called as concentration. The different methods are there to express the concentration. What are the methods? Generally, we are using mole fraction, molality, normality, and molality. In addition to these methods, we can also use volume percentage, volume percentage, weight by volume percentage, weight by weight percentage also. But in this session, we are going to discuss mole fraction. First one is mole fraction. Second one is molality. And third one is molarity. And fourth one is normality. So what are the methods? Are there mole fraction, molarity, molality, and normality. In case of first two methods, mole fraction and molality, independent of the temperature, means if you vary the temperature, the concentration value is same in case of mole fraction and molality. Why? Because the weight does not vary with temperature. But in case of molarity and normality, these values are changes with temperature. Why? Because if you change the temperature, the volume of the solution also changes. Therefore, molarity value as well as normality value also changes. So, among these four methods, which methods are independent of the temperature? Mole fraction, molality, these two methods are independent of the temperature. But molarity and normality depends upon the temperature. So in this session, I will explain mole fraction and molality. Mole fraction and molality. First we know what is the mole fraction. What is the mole fraction? Here mole fraction is defined as it is the ratio of number of moles of one component to the total number of moles of all the components present in a solution is called as mole fraction. What I am saying? It is a ratio of number of moles of one component to the total number of moles of all the components in a solution is called as mole fraction. It is expressed by X. It is expressed by X. Let us take the mole fraction x1 equal to N1 by N1 plus N2. Here N1 is the number of moles of the component 1 and N2 is the number of moles of the component 2. Here the mole fraction of x1 equal to number of moles of given component by total number of moles of the other components. So this is mole fraction of first component. Similarly, mole fraction of second component x2 equal to N2 by N1 plus N2. x2 equal to N2 by N1 plus N2. Here N1 is number of moles of the first component and N2 is number of moles of the second component. Here the total number of moles in the given solution is equals to sum of the N1 value and N2 value. So this is about the mole fraction. Here the mole fraction does not having any units. Why it does not having any units? Because it is a relative property. In case of any relative property, there is no units. And next one is the sum of the mole fractions of a solution always equal to 1. Means x1 plus x2 equal to x1 plus x2 equal to 1. So this is about the mole fraction. So next we go for the molality. We go for the molality. So what is the molality? So in case of molality, the number of moles of a solute, present in 1 kilogram of solvent is called as molality. What is the molality? The number of moles of a solute present in 1 kilogram of a solvent is called as molality. The molality is expressed by small m. Molality is expressed by small m. Here molality small m equal to n by, that is number of moles of solute, by weight of solvent in kilogram. What is the A? Weight of solvent in kg. So molality equal to n by A. So what are the units of the molality? Moles per kilogram. So here units is mole by kilogram. Here we know very well number of moles n equal to weight by gram molecular weight. Weight by gram molecular weight. Therefore, molality equal to weight by gram molecular weight. Gram molecular weight is nothing but GMW into 1 by A in kilograms. 1 by A in kilogram. That is weight of solvent in kilogram. And if you take the weight of solvent in grams, this equation will become small m equal to weight by gram molecular weight into 1000 by weight of solvent in grams. This is weight of solvent in grams. So this is the molality. Here, what are the units of the molality? Moles per kilogram. Moles per kilogram. Here the molality is independent of the temperature. Mole fraction also independent of the temperature. So what I am saying, what is the concentration? The specified amount of a solute present in specified amount of solvent or solution is called as concentration. The different concentration methods are there. So among them, one is mole fraction, second one is molality, third one is molarity, and fourth one is normality. Among these four methods, first two methods are independent of the temperature. Independent of the temperature means if you vary the temperature, if you change the temperature, there is no change in the x value or small m value. But in case of molarity and normality, these values are changes with the temperature, because with the change of temperature, the volume of the solution also changes. Therefore, molarity and normality values also changes. Therefore, the third and fourth one are depends upon the temperature, and first and second one are independent of the temperature. Once again, I am repeating, what is the mole fraction? It is the ratio of number of moles of a one component to the total number of moles of the all the components in the solution is called as mole fraction. It is expressed by x. Let us assume first component number of moles equal to n1, second component number of moles equal to n2, Therefore, x1 equal to n1 by n1 plus n2. Similarly, x2 equal to n2 by n1 plus n2. And the sum of the mole fractions in a solution always equal to 1. Therefore, x1 plus x2 equal to 1. Here it is a relative property. Therefore, it does not having any units. So this is about the mole fraction and molality. Here it is expressed by small m. Here what is the molality? The number of moles of a solute present in 1 kilogram of a solvent is called as molality. Here units of the molality is moles per kilogram. Here small m equal to n by a. What is the a? Weight of solvent in kilogram, and we know very well number of moles n equal to weight by gram molecular weight. Therefore, molality equal to weight by gram molecular weight into 1 by a, that is weight of solvent in kilogram. If you take the weight in grams, the molality small m equal to weight by gram molecular weight into 1000 by a, that is weight of solvent in grams. Okay, and if the solubility is given, in that case the molality equal to solubility into 10 by gram molecular weight. Solubility into 10 by gram molecular weight. We can do molality very easily if the solubility is given. So in the next session, I am going to explain the molarity and normality. Thank you.